When you were writing equations for arithmetic sequences, you had graphs that looked like this. You had a graph with just the upper right quadrant. You had all positive numbers. We had some dots, and we drew a line, and then we wrote an equation. In the equation, we said that this over here was our term on the y-axis. That this was our term, and this over here was our term number. And we decided, all right, we need to find out to write the equation, where does the line start? We drew the line back to the y-axis, and we said, what number is this right here? And we looked at our scale on the left side and went 10, 7, 4, and this was going down by 3, so that would make this line the number 1. So we said our term was going to equal 1, and we looked at our line and said, how are we counting? We were counting by 1 to 4 is 3, 4 to 7 is 3 more, 7 to 10 is 3 more, so we say we're going up 3, and then we put an n back here to say, well, this is then how many times did we count 3? So for example, n stood for our turn number. So for example, if I say 3, I use the turn number 3. 3 times 3 is 9. 9 plus 1, 10. If I follow up from term number 3, I go to the dot. I'll go back to the left and notice I'm directly across from 10. So this is what you were doing at the end of writing sequences. Well, this number right here, when we were doing our counting, plus 3, plus 3, plus 3, notice we were always going over one space each time, and we were going up 3. So we were always counting our 3's, and when we were counting our 3's, we were going over one space. Well, this number actually has a name, and that name is called slope. So just what is slope? Well, slope is this. Slope is how a line moves. It's how a line moves. You compare how the line moves up and down to how far the line has moved to the right. So slope is how a line moves. You compare how the line moves up and down to how far the line has moved to the right. So we're going to take some time to practice counting slope. So let's take a look at this graph now. Notice this graph. Now I have all 4 quadrants here for you. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. So now what you want to do, if you look at the graph, there are no dots. This graph, I had dots here for us, and it was easy to count because we could see the dots. Well, if there aren't any dots, put them in. Well, before you can put the dots in, you have to know where to put them. What you want to look for when you're putting in dots, you want to look for spots where the black line is crossing an intersection. What is an intersection? An intersection is something like this, where 2 lines on the coordinate plane graph cross. Anything that looks like that. You're looking to see where does this black line cross something like that, and mentally put the dots in there. If you're working on a piece of paper with a graph, you can certainly color it on there. So like, for example, on this black line, the best place to start is on the y-axis. And look right here. There's a spot where the black line crosses an axis. It's on my starting point. Remember, we only had the upper right quadrant when we were writing equations. Now we have them all, but you still want to start in the same place if you can. So we start on the y-axis. That is our starting point. And I look and I say, okay, is there another spot like this? Where's the next spot that line crosses? There it is, right there. All right, so now I start on my y-axis, and I ask myself, how many spaces will I go up until I'm across from this intersection? If I count the spaces, I count 1, 2. So I have gone up 2 spaces. How many spaces do I go over to get to the intersection where that circle is? It's 1. So now I can write what my slope is. The slope, we will always use the letter m. M is for how the line moves. That's why we use m. Yeah, slope is used with m for movement. I put the amount I go up on top. I put the amount I go to the right on the bottom. So I've gone up 2 over 1. Up 2 over 1. Since 2 over 1 2 divided by is a fraction we can divide. 2 divided by 1 is 2. So the slope of this line is actually counting 2's. And if you do that, it does count 2 from this spot to this spot. We've gone over one space. We've gone up 2 spaces and over one space. So that one has a positive slope. Let's look at another line. This one, again, I have all 4 quadrants for you. This line is not going up, it is going down as you look at it going from left to right. Let's look at our y-axis. Does this line cross an intersection? Yes, it does, on the y-axis right there. All right, so now let's move to the right along this line and see if we can find another spot where it does. And it does right down here at the tip of the arrow, it would cross on that intersection. So let's see if we can find the slope of this line. So let's write M for my movement or slope, and let's count now. I'm going to count, and since I'm moving down, this is a negative movement. How far do I go down? I go down 3 spaces, so I'm counting a negative 3. Counting a negative 3, down 3. Well, how much do I go over? 1. I've counted down negative 3. I have counted right to the 1. So now I have negative 3 over 1. Negative 3 divided by 1 gives me a slope of negative 3. So if I'm counting down by 3's on this one, down 3 for one space. Here's a third line. Now on this line, as we look at it, if we look at the black line and we look at the y-axis for our starting point, this one does not cross on a nice intersection. It should be crossing here to be on an intersection, or it should be crossing here. But it doesn't. It crosses in a space. That's not a bad thing. It just means we have to count, or we have to start in a different place. So now I'm looking for, where does this line cross an intersection? So I begin to look on, I move to the left side of the line and start looking. Is there a spot where this crosses an intersection? Ah, there's one right there. So I'm going to circle it and say, here's my starting point to count from. Now I'm going to follow my line and I'm going to say, where's the next spot? There it is right there. There's a second spot. And that's all you need is 2 spots like that. You don't always have to be on the y-axis. It's always nice when it's there. We know the starting point is on the y-axis, but sometimes it's not. So let's take a look and let's try to count this now. Let's count the whole number of spaces. How many spaces do I have to go up from this dot on the left to get as high as the dot on the right? So I go up here and say, it looks like I have to count 1 space going up. And how many spaces do I count to the right? 1, 2, 3, 4. So I have 4 spaces that go to the right. So what is my slope? I say my slope, M, equals 1 over 4. You will get some fractions. 1 over 4 stays 1/4. What does that mean? Let's go back and take a look from our starting point. 1/4. That means if I go to my starting point and I count for just 1 space, so if I start at my starting point and go 1 space to the right, how much has this black line gone up? Notice it looks like it's about 1/4 of the box from there to there. Half would be here, 3/4 there. So 1/4. It goes up 1/4 of the box per 1 space to the right. So, the reason why do we need count it the other way? It's easier to count whole spaces. So I count 1 up, 4 right. And finding them using the intersections gives us a nice accurate number for our slope. I could try to count this, but then I would be guessing. So if we count whole spaces, it tells us the exact number. Next line. Here's another line. Doesn't cross the y-axis at a nice spot for us. So what does that mean? That means we've got to, again, find a couple of spots where the line hits an intersection. So let's start over here to the left and see if we can find something. And as we follow along, here's one right here. And I'll keep moving up the line now. And I can keep moving, and I keep moving. And here's another one right here. So now I have the 2 spots that have crossed intersections, and I want to count those. If I count, I'm going to go from here. And how much do I count up? 1, 2, 3 spaces up. How many spaces do I count going over? That's right, 2 spaces to the right. So I say that my slope m equals up 3 over 2. Up or down movement's always on the top. Going to the right is always on the bottom. Up and down is on the top. Going to the right is on the bottom. So now let's see, if it's m is 3 halves, that means that is the same as 3 halves. 3 divided by 2 is the same as 1 1/2. If I start at my starting point and I follow it over one space, will I be 1 1/2 spaces higher than I was before? Let's take a look. Here's my starting point, and I slide up. There's one space, and there's a half space right there, about half. So 1 1/2, so that would be accurate. All right, there's 2 other types of lines that we need to be aware of here. The other 2 types of lines look like this. One is just a straight horizontal line. It's flat. It doesn't go up and it doesn't go down. It's always going right or it's always going left. Well, let's think for a second. If you were actually looking at a heart monitor, what would the number be for that heart monitor for your pulse? That's right. The pulse would be 0. It's a flat line. Anytime you have a flat horizontal line, the slope is always 0. It's not going up and it's not going down, so we have a slope of 0. The other type of line you always look for is the up and down line. Looks like you've fallen off of a cliff. You never know where you're going to end up on the bottom. This one too has a slope, but it has a word name. It's actually called undefined. Undefined is this type of slope. We will be getting into calculating slope in a future lesson, and in that lesson I will explain further as to why we call it undefined. When you see the numbers and do see the calculations, this becomes much more explainable. Please know for now that this is a type of slope. When I see any line that goes straight up and down, it looks like somebody could fall off a cliff and never stop. That is called an undefined slope. Horizontal lines, slope is always 0. Vertical line, slope is always called undefined. Let's take some time now, find the activity in the front table to do some counting of slope, and let's get to work.